So we'll start and try to not take too much time. So we work for Orange Innovation, and during this year, great. During this year, I was Emile's tutor.
So yeah, I'm Emile. I'm doing a work-study program, and I'm doing a master degree in computer science at CPE Lyon. And in parallel, I work at Orange for 3 years.
So for this presentation, I will do a small introduction, and then Emile will describe all the technical aspects. So what can we say? That Orange is well known to be a French telecommunication company, but Orange also works on services. And one of the services we want to deliver in a research project is to try to simplify our customers' everyday lives at work, and not to be in this case. Unfortunately, I cannot describe really this service that is still in development, but I hope it will be available soon. So to try to have a service as close as possible to the user behaviors, we need their data, and as usual, there is a privacy aspect. And for that, we have chosen to use a federated learning approach. But the main point was to see which federated learning library. So we have done a benchmark with different targets, and it appears that Flowers was the best one for our use case and calculation. Nevertheless, there is still an issue. A little constraint is that the service we want to deploy on the user computers is done in Node.js. And the thing is how to make that compatible, how to make Node.js compatible with Flower. So now I will let Emile describe to you all the technical aspects.
So our goal is to keep Flower working as it originally. So you have a client that communicates with a server. We just want a client in Node.js communicated with a Python server. So we will replace the original Python client and replace it with a Node.js client. Thanks to the help of the community, in particular Daniel and Tana, our client is existing and functional. Our code is open source. By the way, you are open to any modification or problem escalation. You can find our repository called flower-node.js-client on GitHub under the license Apache 2 in the Orange open source community group. It is covered by it is covered by unit tests at about 80%, and some example is available inside the repository. In addition, our client is available on NPM platform right now. So you can find it by searching Flower-client on NPM. Yes. For the moment, our client has been tested on version 18 of Flower. It will be soon make an adaptation if necessary, so that the client is compatible with the version 19. The next thing to implement is the issue of protocol buffer, because for now I create a simple JavaScript object with share, and it will also be necessary to set up a continuous integration chain, launching unit and integration tests and code quality. If you see any inconsistencies or errors, I am open to exchange with you. So how does it work? First, you must install all the necessary tools, such as Python with the version greater than 3.6, Flower in version 18, and Node.js and NPM. Then create your working directory, place yourself in it, and initialize NPM directory. Next, install the necessary package. It was called Flower-client, so NPM installed the Flower-client, and create your client. So I try to take as much of the logic already present in the Python version as possible. So you just have to import TensorFlow and the template of the client class and overload the later with your model and your method, as in the example here, like in the Python version. You also need to provide the model. I did here in the constructor, but it does not matter where you create it. Pay attention to the get properties function. I haven't tested yet, so it can have a problem. For the moment, our client is compatible with TensorFlow.js, but you have to be careful. Two versions exist. The first, TFGS-Node, is faster, but requiring Python 2.7 on your machine, computer. And the second, TFGS, is slower, but no crazy. It didn't require both versions have the same APIs, only their execution speed change. I haven't tried TFGS GPU version. And now you have to overriding the structured method. So I base my code on the version 18 of Flower, so I don't use the serialization system implemented in version 19, but it will be soon. On this side of Python server, you just have to redefine the function wait to parameter, parameter to wait, array to byte, byte to array, as an example. NumPy does not exist under Node.js, so I share a list of float 64 array between the server and the client. By the way, you can find this code also in the example folder on GitHub. And the final step, configure and launch federation. So remember to configure your server and prepare the launch of your client, as in the Python version, using start TFGS client and renewal. And voila, it's worked. Now I will show you the execution of the previous configure federation. In this instance, I have created a 3-layer model whose purpose is to predict the input number +1, so a simple task. I launched the server, connect one client, he sent the model by using get parameter, and I launched the second client, and the federation is running. For the moment, I left the message receive and send, but it will be necessary to set up a more readable log system. You can see the 10 rounds are done, and at the end you can see the mean square error result of the rounds, and that's all. To conclude, we have a functional Flower client in Node.js, open source as usual, available to everybody. Sorry, high test coverage for a POC, 80%. 80% tested. We probably add some additional tests in the future. So feel free to use it and maintain it and develop it if you want. Thank you.